Hello, everyone, and welcome to Best Practices for Data Protection on Amazon S3. My name is Rob Wilson. I'm a product manager on the Amazon S3 team, and I'm joined today by Bajeta Chakraborty, who is also a product manager on S3. So we're very excited to talk to all of you today about some of our features that help in the data protection area. And without further ado, let's dive in. So a lot of customers wonder, what's included in data protection? What's really encompassed by that term? And it really is made up of two major things, the way I look at it. It's corruption and data loss, which potentially would come from the hardware that data is stored on, or how redundantly a copy of data is stored. So that's one thing, and that really goes to how the data is physically stored on devices. And for S3, that really speaks to our durability promise, our 11 nines, and everything that goes into that. The other part is the potential risk of accidental deletion or malicious deletion. So that could be overwrites, modifications, or deletions. And that really comes back to user action. So what users have access to the data, what changes can users make, and are there data protection features or other functionality in place to prevent that or mitigate the risk of that happening? And the last thing I'll mention is the one I hinted about with the durability of Amazon S3. So the whole concept of data protection builds on the storage system you're using and the platform itself. So what are AWS and Amazon S3 doing to store your data durably? We'll talk about those in detail, but data protection really builds on that foundation. So not only is your data durably stored, but we're going to talk about features and functionality that you can layer on top to add even more protection when storing your data. Our agenda for today is going to start with an overview of the Amazon Simple Storage Service, Amazon S3. We'll then talk about the durability that I outlined earlier, go into our features like object versioning, multi-factor authentication, replication, and object lock. At that point, with the foundations of how all those features work, we'll go into a demo where we talk about either how to get started with a particular feature or one of the key pieces of functionality. So here's an option you all want to look out for, or here's something to go to the console and get started here first. Here's the easiest way to set this up, for example. Those are the types of things we want to highlight in the demo and show you really how these things work in the console. At the end, we'll have time for Q&A. So as we're going along with this webinar, really think about those questions, where you'd like an additional clarification or where you want to dive into more detail. We'd love to have that conversation with you at the end of the webinar and look forward to your questions. So we'll now jump into the Amazon S3 overview. And this is kind of a primer for folks that might be less familiar with Amazon S3. But even if you have been using Amazon S3 for years, hopefully there's a few things here that'll set up the rest of the conversation about data protection and also maybe recap something you haven't seen in a little while. So on the availability side, we have availability designed as high as 4 nines with some of our storage classes, like S3 Standard. So with the availability of Amazon S3, you know your data is going to be there and available when you need it. And we do have a service level agreement guarantee behind our availability. On the durability side, we have our 11 nines of durability that are offered with Amazon S3. On the security side, both with Amazon S3 and the Identity and Access Management Service, you have the possibility with policies to be very granular with who can access the data, who can perform particular actions with Amazon S3. And then you have things like umbrella policies, like block public access, that can apply at both the bucket and account level to make sure no public access is granted for your data. And that's regardless of the permissions in place. So if your bucket policy allows public access, but you enable block public access, that's something where it overrides that policy and ensures that no public or anonymous access is granted to the data. On the manageability side, we'll talk about replication today, in large part and how it interfaces with data protection, but we'll also hint at Lifecycle. And I want to highlight that a little bit now. Lifecycle is a feature in S3 where you set rules, and then those rules automatically apply actions to your data when those rules are met. So for example, if you know your data is less frequently accessed after 30 days, you want to then use a storage class best designed for that infrequently accessed data. So you can set a rule saying that any object over 30 days old transitions to standard infrequent access, maybe one zone infrequent access after that period of time. So then you're paying less for the storage. It's a better fit for the less frequently accessed data, and it's all automatic for you. So once that rule's in place, it's something you don't have to think about anymore. On the performance side, customers are very excited as they scale up in S3 to see how well S3 scales with them and scales horizontally. So the more data you store in S3, the more objects you store, you can achieve higher amounts of throughput to those data sets, and that grows with you over time. So as your data needs and data access needs grow, Amazon performance will scale with that. On the scalability side, similar story. And I think customers are really excited when they start to dig into S3 and start using S3 to know that when they start a new business or a new project, you can go from storing a handful of files initially to then growing to terabytes, petabytes, exabytes over time as your business scales. So that gives you the ability to know that you're going to use Amazon S3. You'll have the pay as you use it pricing model throughout, even as you scale to those higher thresholds of storage. And comparing that to possible alternatives like an on-premises storage system, where you might have limits in facility size, how many rack positions you have. With Amazon S3, you're going to continue to scale, and all of that work is handled by Amazon S3. On this next slide, I want to outline our storage classes we have in Amazon S3, because this will serve as a good foundation for some of the topics we're going to talk about later on, especially things like versioning, things like replication. You'll see storage classes come up a few different times. So on the left side of this slide, you have S3 Standard, really designed for the more frequently accessed data, active data sets. It can be used for objects from the smallest size objects to objects terabytes in size, and you're going to get millisecond access greater than or equal to 3 availability zones, and for only about 2 cents per gig per month. So you have a good price point there, and you have something that can work for really any particular data set. In the middle of the slide, I want to shift next to the infrequent access storage classes. So this is standard infrequent access and one zone infrequent access. Both of them, as we talked about before, designed for those infrequently accessed data sets. So when you're storing here, you expect the data to be accessed less frequently, and so does S3 in the way we store it. So this data, and looking at the price points compared to S3 Standard, are usually a good option for any data that's accessed 1 or less times per month. So if on average your data set's accessed less than that period, then the retrieval fee associated with infrequent access makes up a very small part of your storage bill, and it saves you money overall. So you have that choice of then moving to infrequent access, maybe after 30 days, maybe after a longer period of time, but aligning with when your data becomes less accessed over time. And in between those options, standard and infrequent access, you have S3 intelligent tiering. And this is a storage class where it automatically tiers the data between a frequent and infrequent access tier based on the access patterns. So you then get the benefit of that being automatically managed on the S3 side, where when the data is accessed, moves to the frequent tier, stays in the frequent tier for a period of time, and then after 30 days of not being accessed, it moves to the infrequent tier, and then you're paying the price point of standard infrequent access. So you can achieve up to about 40% savings in intelligent tiering when your data shifts to that infrequent access tier. So it can be a really good choice when the data access patterns are uncertain or they might be changing over time. When they're more predictable, maybe you just manage the lifecycle yourself, but when they're less predictable, intelligent tiering gives you that flexibility and moves between the different tiers. On the right side of this slide, we have Glacier and Glacier Deep Archive. So these are designed for those archive data sets. They might be data sets stored for a longer period of time, and they're going to give you that lower price point. They're still stored in 3 or more availability zones. They're durably stored, and then it takes either minutes or hours to access the data. So you have flexibility there with Glacier to access the data in minutes. It is designed to be less frequently accessed. It is designed to be archive data sets that it might be retained for a longer period of time. But when you do need to access it, you have different retrieval tiers that you have options to do, and you can get the data back in as few as minutes using S3 Glacier. So you have flexibility here with all our different storage classes we're highlighting to get a different price point, to get different performance characteristics, and different access patterns depending on how you're using your data. So with all of that as background, we'll now talk about S3's durability. And this will serve as a jumping off point to the rest of our conversation about data protection, because durability is really the foundation that builds upon. So now we'll go into Amazon S3 durability, and we'll start with our 11 nines of durability. So that is the number that we target. That's the number that we hold ourselves to when we're building our systems and monitoring them and updating them over time. So that goes to how we store the data, which is across multiple devices, and then also across different availability zones and data centers. So when you're comparing the durability of S3 with the durability of other solutions you might be looking at, with S3, you're going to be storing it in AWS regions, where there's a minimum of 3 or more availability zones that your data is stored across, and then there's 1 or more data centers in each of those availability zones. So you have data that now is stored across more facilities and has less points of failure, or distributed in terms of what possible failure points could be. And then the data integrity checks we're doing are then part of that story as well. So this is data integrity checks on the data at rest and in transit to make sure the data you send to S3 is the data that's stored and the data that's maintained over time. On this next slide, we go into a bit more detail about the availability zones and the data centers, and you really see how that architecture is to your benefit. So the availability zones are separated by miles. You have redundant dedicated network interconnects between the different facilities where your data is stored. Then you have independent power infrastructure, and all of this feeds into the fact that we're able to durably store your data across in all storage classes except for one zone infrequent access. It's in 3 or more availability zones. With one zone infrequent access, your data is stored in 1 availability zone. So it's something where maybe less resilient to certain types of failures, but it is at a lower price point. So when you're considering the different storage classes, that's something to think about. And then I mentioned the video earlier about S3's culture of durability. So there is a link there and can be something to follow up on this session as well, which goes into more detail about the integrity checks, how we do change management in S3. So all of that is covered in more detail in the video. Our first feature we're going to talk about in detail is S3 versioning. So object versioning is another way of referring to this, and it speaks to the fact that when you're overwriting a piece of data, for example, you're now maintaining multiple versions of that piece of data rather than just overwriting it and maintaining the latest version. And that versioning is going to allow you to preserve, retrieve, and restore your data. So it gives you the ability to roll back something like an overwrite or a deletion, depending on how that deletion is performed. So let's go into more detail on version. Enabling S3 versioning is something that you can do on a new bucket or an existing bucket. And it helps to protect your data from accidental deletion, and we'll talk about how some of that comes into play. So each new version you upload creates a new version of the object. So here's a simple scenario where we're putting this photo file into our bucket. That first photo that's added is version 1 for this simplified example. And then the next one, you now see that both objects are preserved. They're different versions of the object, and then they have a unique version ID associated with them. So that second point there on the slide is that when you delete the object, when you just say delete photo without a version ID specified, that's one behavior where a delete marker is created. And we have another slide covering that in detail. But you can also choose to delete an object with the version ID specified. So in this case, you could specify delete the object version ID 2, and then that data would be permanently removed at that point. And you then, as we look at the stack and how different objects can be added over time, you could have many versions of a particular object. And lifecycle policies then give you the ability to say, well, I want certain rules to apply to the current version. So basically the latest version that was added. In this case, it would be that photo version 2. Or you can set lifecycle policies that apply to the non-current versions. So that would be all the other versions of an object. And having the ability to transition them or expire them with different rules set on your lifecycle policy gives you a lot of ability to then be very granular with retention periods and control cost. Especially when all the new versions on an overwrite are maintained, you might choose to, after a period of time, expire those objects or transition them to a lower cost storage class. I wanted to show a version ID example right after that because we were using a simplified example of version 1, version 2, but it really is a unique character string. You see it here in the version IDs showed on the console, where it is many more characters than what we showed on the previous slide, and that makes sure that those versions are each uniquely identifiable and something where you can go back to the previous version history and be very clear about which version you're looking to access. Here's an example, and we'll talk through once again kind of how versioning works, but go into a few different scenarios here. So in our put object, our initial case here, we already have versioning turned on for the bucket. We've added a new object. Now we have flight PNG and it's version ID 1. Interestingly, if we did not have versioning turned on for a bucket and we're adding objects over time, and then you enabled versioning later on, all of those objects already in the bucket would be a version ID null. So you wouldn't have that differentiation because without versioning turned on, each object key would only be associated with one object. All of those version IDs would be null. In this case, with versioning already enabled, that object we add to the bucket, it has a version ID right off the bat. We then add another object to the bucket, same key name, so that's why the two objects are associated with one another. They have the same key name, that flight.png, and now we just have another version of the object. So you see now we have a current version and a non-current version. And I wanted to make that very clear on a slide, so when we talk about lifecycle policies, you can see the difference there. The next thing we're going to do in this bucket is delete the object. And what we did here was we said delete flight.png. We didn't say anything about version IDs in that request. So when we issued a delete without a version ID specified, what it does is actually adds a delete marker. It doesn't remove any of the previous versions, it just adds a delete marker. So the behavior that happens now is if I do a GET request on flight.png, what S3 sees is a delete marker because that's the current version, that's the latest update. So you'll actually get an error saying the object doesn't exist. Because even though your data is still stored as version 2 and version 1, this previous history of the object, it's not accessible. It's not seen by S3 because what we're seeing is a delete marker. Now, if you did a GET on flight.png version ID 2, you would get that data. Or you could do it with version 1 and get that data as well. So you have the option to access the previous versions, but a lot of applications will do a GET on just the key name. So that's how this behavior works, such that when you do want to delete an object, we put that delete marker in place, gives you the ability to potentially roll back to a previous version or to remove that delete marker if that's unintended. But when you do want this data to be inaccessible to an application, for example, that delete marker being there does accomplish that purpose. The other thing we're going to show here is now we have that delete marker in place. We didn't want it there anymore. We then removed that version ID 3, which was the delete marker version, and now we are back to the state we were in before. So that delete request added a delete marker, then we remove the delete marker. Now, once again, version ID 2 is our current version, and we have a non-current version as well. So you see kind of how step by step, we got to the place we wanted to be in our bucket, where our data is restored, and once again, accessible to our end users. On this slide here and the next slide, we'll then talk about how lifecycle policies can be used with versioning to give you the ability to potentially save money on the non-current versions. So in this case, we do want to maintain our non-current versions. We're not expiring them in this example. And walking down the lifecycle configuration, you have the ability to name your rule. So you can add an ID that helps you uniquely identify each rule, understand why was this rule put in place, what team put the rule, for example. You can put different information in that ID. Then you have the ability to set filters by tags. So what tag is on a particular piece of data, or what prefix. And prefix within S3 is just a way to organize your key names such that you can have different prefixes within the bucket and store objects uniquely in different prefixes. Down below that, we have status enabled. So this is a lifecycle policy we want to be active. It's on non-current versions, and it's for transitioning them after 30 days of being non-current. So really interesting thing to look at here is it's not from the object creation date, it's from when the object became non-current. So what that would be based on in our previous example is that version ID 1 of flight.png became non-current when version ID 2 was added. That could be on the same day that version ID 1 was added, but it could be much later. So the trigger here for a non-current version policy is how long the object has been non-current. So that allows you to really be granular, and really it better aligns with how you think about the data, where when this object was overwritten, that's kind of T1 or day 1, 7 days later, I want to remove that object or transition it because it's been non-current for 7 days. We're kind of in a state where the system's running, the application's running, everything's working fine. 7 days later, you can expire that or transition it. So that trigger point is when it's non-current. And in this case, we're moving it to the standard infrequent access storage class. And that's as simple as setting up these rules. So this is one view of it. You could also do it in the console. That would be an alternative as well. On this next slide, we'll talk about actually expiring non-current versions. So it's a non-current version expiration policy. After 7 days of being non-current, I want to expire this object. And what that will do is permanently remove the object from the bucket. So this is a way to control cost. It's something that you can put in place to remove non-current versions after a particular number of days, in this case 7. But depending on your business, that could be a shorter period of time, could be a longer period of time. So we have a slide later on that talks about rolling back deletions, for example, or rolling back overwrites. This particular, when you put in a expiration policy, is giving you that window of time to identify that something was unintended and then bring back that object. So the longer period of time you set here, the more time you'll have to identify something and then correct it. S3 versioning is as easy to set up as going into the Management Console, opening up the S3 console. You're choosing the particular bucket you want to enable versioning for. You go to the Properties tab, choose versioning, and then you can enable or suspend versioning from that screen. Here's that slide I talked about with having a recovery window for your versions of objects in Amazon S3. So this is kind of a do-it-yourself recovery bin is one way to look at it. You've turned on object versioning for a bucket. You've set up a non-current version expiration policy for a number of days. So we're talking here about setting that policy because we want a fixed period of recovery window. If you want an infinite recovery window, there's another way to go through that, which would be just to not set that policy. And then the non-current versions, unless any other action was taken, would just stay in the bucket. So you'd have more time to recover it, but depending on how frequently data is turning over in the bucket, that may lead to higher storage costs over time. And then here, I'll just talk through the example because bullet point 3 really talks to the number of days you can recover objects for. We'll use 7 days for that period of time, but let's talk through it kind of step by step so far. So August 26th, we upload an object to Amazon S3. A month later, we delete that object. So this was a delete request without the version ID specified. If we did specify the version ID, that object's permanently deleted at that moment. So there's ways to limit that permission and who can access that type of deletion. And there are ways to control that in your bucket if you want to. But in this case, we're looking at object was deleted, no version specified. So that object became a non-current version, there was a delete marker added to the bucket. If we use the example we talked about before with an expiration policy of 7 days, then it would be 7 days after September 26 when the object would be permanently removed and when that non-current version expiration policy would be applied. So then that recovery window is 7 days. If you notice errors in the application, if somebody manually is looking for an object and doesn't see it, or looks deeper into the bucket to look at the version history and sees the object is still there as a non-current version, these are the things that potentially would trigger you to either copy that object, remove a delete marker, take another action to bring that object back to a current state, move it to a different location, or if a customer noticed that data was unintentionally deleted for whatever reason and things were now in this non-current state and might be expired in 7 days, disabling that lifecycle policy or removing that lifecycle policy is then a way to kind of stop that deletion process from occurring. So you've got this recovery window, you've got different ways to make changes to either bring the object back or remove that expiration policy. So definitely wanted to talk through this example with all of you. In this next topic, we're going to talk about multi-factor authentication, which a prerequisite for is versioning. And then it also is coupled with how the versioning is set for a particular bucket. So we'll talk through that example now. Multi-factor authentication is another layer of protection for deleting objects or changing the versioning state of the bucket. So for those buckets where we enabled versioning, you can set it up such that multi-factor authentication is required to suspend versioning on a particular bucket. So that's one thing to do. Multi-factor authentication at a high level refers to having that other form of authentication. So this would be a device with a unique serial number. This can be a token that'll be reset over time. And that can be something that's virtual or a physical device. So you're combining both your user credentials and kind of your security credentials on AWS, plus having this unique code with an authentication device, and you're using that together to be your multi-factor authentication. And what this means on the delete side is that you can set up the policy such that to delete any objects from a bucket, you need to have the multi-factor authentication. You need to have both the credentials to issue that delete, and then also have the device and the authentication code displayed on it. So it sets a much higher bar for deleting data from this bucket, having that additional verification, that additional check. And here you see on the XAMZ MFA, you see the device serial number and then that authentication code. So this is then required to actually delete objects in that multi-factor authentication enabled bucket. So definitely speaks to data protection. It's a much higher level of kind of permissions required and the bar required to actually remove data for that particular bucket. So a best practice would be if you have content that it should be very, very rare to delete data or almost never, you'll have object lock as an example and a possibility to use for that bucket, but MFA is another thing to consider as well. At this point, I'll turn the presentation over to Bajeta, who will talk through replication, and I'll turn it over to her now.
Thanks, Rob. Hello, everyone. Now let's talk about S3 replication, common use cases, and configurations. We have 3 different replication product offerings: same region replication, cross-region replication, and replication time control. You can choose to use either or a mix based on different workload requirements. We typically see 3 use cases for customers that use same region replication: aggregating logs, prod and test account setup, and abide by data sovereignty laws. Number 1, aggregate logs. If you store logs in multiple regions or across multiple accounts, you can easily replicate logs into a single in-region bucket. 2, configure live replication between production and test accounts. If you or your customers have production and test accounts that use the same data, you can replicate objects between those multiple accounts while maintaining object metadata. And 3, abide by data sovereignty laws. You might be required to store multiple copies of your data in separate AWS accounts within a certain region. Let's talk about cross-region replication, or CRR. CRR can help you meet compliance requirements, minimize latency, and increase operational efficiency. 1, compliance requirements. Although Amazon S3 stores your data across multiple geographically distant availability zones by default, compliance requirements might dictate that you store data at even greater distances. 2, minimize latency. If your customers are in 2 geographic locations, you can minimize latency in accessing objects by maintaining object copies in AWS regions that are geographically closer to your users. And 3, increase operational efficiency. If you have compute clusters in 2 different AWS regions that analyze the same set of objects, you might choose to maintain object copies in both of those regions. The third product offering is S3 Replication Time Control, or RTC, that comes with a time guarantee of 15 minutes and helps you meet compliance or business requirements for data replication, and also provides visibility into replication times. More about replication. For all replication rules, you have the flexibility to replicate at the bucket, prefix, or object level. As a best practice, you want to also think about replicating data to a different storage class from the source bucket. For example, if your secondary copy will be accessed less frequently but requires rapid access when needed, consider standard infrequent access. Or let's say you have a data archival use case and you're looking for a secure, durable, and low-cost storage class, then Glacier or Glacier Deep Archive may be the right options for you. In the next few slides, we will present a few replication examples. Setting up replication when source and destination buckets are owned by different AWS accounts is similar to setting up replication when both buckets are owned by the same account. The only difference that I'd like to highlight is that the destination bucket owner must grant the source bucket owner permission to replicate objects by adding a bucket policy. Let's quickly look at the steps. First, you will create a source bucket with the first account and enable versioning. Second, create a destination bucket with the second account and enable versioning on that as well. Next, you will need to create an IAM role for each account and attach the required permission policies. Finally, you will need to allow the source bucket to put object replication on the destination. Replicating cross accounts is a data protection mechanism. Customers often add optional configuration settings to change replica ownership to the AWS account that owns the destination bucket. You can try this to restrict access to your object replicas. Next, we will see what the replication policy for the cross account looks like. This is an example of the bucket policy on the destination bucket for a cross-account replication configuration. See here highlighted how we're allowing the source account IAM role to do 4 things. 1, replicate the object. 2, delete replication. 3, get versioning and put versioning on the destination bucket. RTC helps you meet compliance or business requirements for data replication and provides visibility into S3 replication times. Typically, S3 RTC replicates most objects that you upload to S3 in seconds, and 99.99% of those objects within 15 minutes. It's interesting to note that RTC is backed by an SLA that states that customers will be eligible to get a service credit in the event that AWS S3 does not meet the RTC feature commitment of replicating 99.9% of objects within 15 minutes. RTC has metrics with which you can monitor your replication progress. Replication metrics are available through the Amazon S3 console and the Amazon CloudWatch. RTC also comes with events that notify you in the rare instance when objects do not replicate within 15 minutes, and when those objects replicate successfully to their destination region. You can configure and subscribe to RTC events through Amazon SQS, SNS, or Lambda. This is an example of an RTC rule that we set up on one of our test buckets. With this RTC rule, we are replicating between 2 regions, Ireland to US West, and the storage class of the destination is kept the same as the storage class of the source. RTC has 3 different metrics. Number 1, bytes pending replication that shows the total size of objects pending replication. 2, operations pending replication that measures the total number of S3 API operations that are pending replication. And number 3, replication latency, the maximum replication time to the destination region. Out here, we've pulled up the CloudWatch dashboard to showcase bytes pending replication. This graph usually peaks in the middle of the replication window before dropping to 0 near the 15-minute mark. You can also see in the bottom half of the CloudWatch screen the other 2 metrics, operations pending replication and replication latency. We show you example graphs for all of these 3 metrics in the next slide. On this slide, we can see example graphs for all 3 metrics. You can filter these metrics at a replication rule level. It's good to note that operations pending replication will include replication of ACL and tags. These are 0-byte operations. So if you, for example, have one object tag that is pending replication, you will see 1 operation pending replication and 0 bytes pending replication. I'd also like to draw your attention to replication latency. It's an important metric for many of our customers, especially for organizations that are governed by strict compliance requirements. For example, we have financial organizations that are required to maintain less than 1 hour recovery point objectives. Replication latency tells you the maximum amount of time that the destination region is behind the source region for the given replication rule. If your replication latency is 80 seconds, as seen in the image on the bottom right, that means if you were to fail over to the destination bucket, you would be able to recover all operations up until t minus 80 seconds. RTC has 3 primary events, and customers can monitor these events through SQS, SNS, and Lambda. The 3 events that we want to highlight today are S3 replication operation failed replication, S3 replication operation missed threshold, and S3 replication operation replicated after threshold. In this slide, we demonstrate how a customer might use operation missed threshold and operation replicated after threshold to monitor their RPO. Say we upload an object to the bucket at 9 a.m. Due to an unforeseen outage, our new object does not replicate to the destination region in 15 minutes. At 9:15, Amazon S3 emits operation missed threshold. Object replicates to destination by 9:18, and S3 emits a new event, operation replicated after threshold at 9:18. With this example, we wrap up the replication section. Next, let's dive into the last feature for today's webinar, object logs. S3 object log. Object logs are a good way to protect critical objects from getting deleted or overwritten. With S3 object log, you can store objects using a write once, read many, or worm model. Some of our customers have regulatory requirements that require worm type of storage. Object logs can be set up at the object or application level or as a default bucket level setting. We'll show you examples of both in the following slides. Object logs provide 2 ways to manage object retention periods and legal holds. And we will also dive into the differences between both. It's good to remember that versioning is a prerequisite for object logs. Let's talk a little bit more about retention periods and legal holds. A retention period specifies a fixed period of time during which an object remains locked. During this period, your object is worm protected and cannot be overwritten or deleted. A legal hold provides the same protection as a retention period, but it has no expiration date. Instead, a legal hold remains in place until you explicitly remove it. Legal holds are independent from retention periods. As long as the bucket that contains the object has object lock enabled, you can place and remove legal holds regardless of whether the specified object version has a retention period set. There are 2 types of object lock modes, compliance and governance. These retention modes apply different levels of protection to your objects, and you can apply either on your objects. It's important to note that the compliance mode disallows deletes even for the root account. The governance mode, in contrast, protects objects from being deleted by most users, but allows some users with privileges to change settings or delete protected objects. As a best practice, you can use the governance mode to test retention period settings before creating a compliance mode retention period. Please note that the user will need special permissions and request headers to override or bypass governance mode. On this slide, we have a visual where you can see that we've put a retain until T10 on an object today. This object log will expire 10 days from today. Sometime in the future, we can also put a legal hold on the object and remove the legal hold 12 days from now. And that's independent of the retention mode. Next, we will see how to apply an object log as a bucket default setting. When you use the default bucket object log setting, you don't specify a retain until date. Instead, you specify a duration in days for which every object version placed in the bucket should be protected. In this slide, we have set up a retention period to 2 days from now. When you place an object in this bucket, S3 will calculate a retain until date for every new object version in the bucket. It's important to note that when you enable object lock at the bucket level, it does not mean that all objects added to the bucket will be protected by default. If you'd like to protect all objects by default, you will need to configure a default retention period. Default retention period applies to all new objects that are placed in the bucket, unless you explicitly override the default settings at the time of new object creation. Something to note here is that you can only apply object locks on a bucket at the time of the bucket creation. To do this for existing buckets, you will need to contact AWS support. With that, we complete the topic of S3 object locks. Now, let's switch over to go see some demos. Today, we will demo 3 different things. 1, versioning, 2, replication, and 3, object locks.
All right, so let's jump into the demo. We're here in the AWS Management Console, and we're going to start by jumping into the S3 console. The first demo we're going to do, as Bajeta talked about, was looking at versioning. This will be a quick demo, but we want to look at a particular bucket where versioning is enabled and show you how objects will be displayed in a versioning-enabled bucket. So right now, as Bajeta scrolls down, you see that each unique object key just shows 1 entry right now. But if Bajeta shows the object versions, you'll see that there are actually multiple versions for each one of those objects. And maybe Bajeta would want to consider setting a lifecycle policy in the future or doing something else to either limit or control the number of versions that are retained. One interesting thing to mention here is that the list API call and S3 inventory can also be used in a similar way, where you can say, I only want to see the current versions, or I want to see all versions of an object. Excellent. So that's what we wanted to show you on versioning. Now we're going to go back and set up a new replication rule for one of our buckets. So Bajeta is going to go ahead. She's going to the source bucket for the replication. So this is the bucket where we'll be uploading our objects. And when they're uploaded, then they'll automatically follow the behavior specified in the replication rule. So we'll go into the Management tab, take a look at replication. And at this point, we don't have any rules set up. So we're going to do the getting started. We're going to walk you through step by step on how to do that. So Bajeta has important data in this bucket that she wants to replicate, but not necessarily all data in the bucket. So she is going to specify a particular prefix when setting up this rule. And as we mentioned during the presentation, this is a way you can potentially limit the cost or at least focus on which objects are most critical that you want to have replicated. So scrolling down here, we've now got our prefix specified. And these are not KMS encrypted objects. So at this point, we can just move to the next screen. So here, one of the things we want to look at is starting off with the fundamentals. We want to set our destination bucket. Where do we want these objects replicated to? And Bajeta is going to scroll through and select the destination bucket. Now we're going to scroll down. And one of the things we want to do here, because this is a second copy, we want the redundancy of having an additional copy, but we want to change the storage class because we want this to be as low cost as possible. We're going to have our source objects potentially in standard, but we can have those destination objects in a different storage class. So I'm going to select a lower cost storage class, and now we have a blended storage rate between the 2 buckets that's a little lower for us. Scrolling down, we also want to turn on replication time control. This is important data. We want to make sure it's replicated in 15 minutes or less, and that's something where it's just as simple as clicking that checkbox to enable the setting. Move on to the next screen. And at this point, this is that IAM role that Bajeta talked about, where you need the right permissions to perform replication. So S3 is going to be assigned a IAM role, and then it's going to perform the replication on the customer's behalf. So the IAM role, we're actually going to create a new rule, and that's going to a new role, and that's going to make sure we have the right permissions for replication. We're going to give that a name that once again makes it easy to identify, and then we're enabling the replication rule. At this point, we want to validate that everything looks correct. Our source bucket, destination bucket, we're changing the properties of the objects to be in standard and frequent access. So You're going through these steps, making sure everything meets your expectations. And then once we save that, because we enabled the rule, it's going to be in place. We could go ahead and start uploading objects right away. For the purpose of this demo, though, we wanted to create the rule, and now we want to look at object lock. So we're going to now go back to our list of buckets. We're going to select a bucket that is already enabled for object lock. So this is a setting where you enable object lock for the bucket, but then setting a default object lock setting or assigning object lock settings or legal holds to individual objects is then separate on top of that. So we've got a bucket, it's object lock enabled, and now we want to set a default to make sure all new objects inherit a retention date from the time of creation to the number of days in the future. So we're going to scroll down here and go to object lock. As we talked about, object lock is already enabled for this bucket. That's the permanently enabled. So Bajetta, we want to make sure that we're enabling governance mode for all new objects. And let's do that for 365 days. Let's make sure it's 1 year. Let's get that full coverage we want for these objects. So governance mode, as we talked about, it can be overridden as needed, but now we have that level of comfort and that peace of mind knowing that objects are locked just as soon as they're added to this bucket because we have this setting in place. So let's save that. And we have this confirmation screen here because we want to make sure object lock is set up right, especially when you're talking about compliance mode where there's no way to override it. That's something you absolutely want to get right. And with governance mode, for a full year, retaining those objects, something where we want to put that confirmation screen in place. So with that, we talked through versioning, talked through a replication rule and set it up. And then we wanted to highlight that object lock default setting because it's just so important and it handles it automatically for you. So that concludes our demo, and we'll jump back over to the slides. All right, so now that we've walked through the demo, we're back for the Q&A portion of the presentation. So make sure you're submitting your questions. We'll be answering them along the way, both in chat and over voice. And we'd love to get your input. We'd love to get your questions and engage more on the topic of data protection. And thank you very much for taking the time to spend with us today. So I'm Rob Wilson, Bajetta Chakraborty, and I. We enjoyed putting this presentation together for you, presenting it to all of you. Thank you for your interest and continued usage of Amazon S3. Hope you have a great rest of your day. Thanks for all your questions. Bye-bye.